The 2018 Robert Millikan Medal is awarded this year to Dr. Kyle Forinash, an emeritus professor of physics at Indiana State University. Dr. Forinash, would you please come up and join us? Me. There's no reason he shouldn't be embarrassed as much as everyone else, I think. Dr. Forinash is an emeritus professor of physics at Indiana University Southeast, New Albany, Indiana. In nominating him for this honor, his colleagues noted his remarkable career as a physics educator with an interest in societal issues and as a department chair who has shaped the curriculum at his university and as an author. Dr. Forinash received his BS from the University of Georgia, after which he worked as a physics teacher with the Peace Corps in Ghana. Thank you. He completed his PhD at the University of Clemson while he worked as a teaching assistant before taking a position at Indiana University Southeast in 1985. He was visiting assistant professor at East Tennessee State University. Dr. Forinash was coordinator of physics at Indiana University Southeast for 32 years. During this time, he was a Fulbright scholar in Argentina, a visiting scientist at Los Alamos, and the author of a BA degree program with a physics major at Indiana University Southeast. He has produced two high-quality interactive electronic textbooks, which are available from the AAPT Compadre website. First is Sound, an interactive ebook, is an introduction to the physics of sound and waves, an interactive tutorial, and includes advanced material on waves, nonlinear waves, and solitons. Waves received 2 awards for online materials, the Multimedia in Physics Teaching and Learning, and the NPTEL Excellence Award for Multimedia Resources, and the Multimedia Education Resource for Learning and Online Teaching Award for Exemplary Online Learning Resources. His most recent book, Physics and the Environment, was published by IOP Press in 2017. For this and his many accomplishments and his work advancing physics education, AAPT is happy to present the 2018 Millikan Medal to Dr. Kyle Forinash. I would be remiss at this point just not to mention that there was one additional Distinguished Service Citation that was awarded this year, but the presenter has chosen to have it, the awardee has chosen to have it presented at the 2020 meeting in Grand Valley State University, and I'm sure you will all recognize the name of Dr. Warren Hine. Dr. Forinash, thank you.
Okay, well, thanks. I want to thank the AAPT committee for selecting me. I was stunned and surprised to have even been considered for this award. I also need to thank these people. I wouldn't be here without my colleagues. We're only as good as our colleagues, and I'm going to mention these people a little bit later. I also need to thank my family. My family put up with listening to me give all kinds of explanations of the Bernoulli effect, conservation of angular momentum, lasers, all kinds of stuff, and they always pretended like they were interested and were polite about it. So I have to thank them for that. I think when I got the award, I asked, what should I talk about? And the response was, well, you can talk about anything you want. And I thought about that for a while, and I thought, well, this is kind of dangerous. I could end up really doing something crazy. But so I went back and looked at some of the previous talks, and I also looked at some of the things, some biography material about Millikan. And he got into physics teaching in a very odd way. He didn't start out to be a physics teacher. So I thought that what I would start out with was just a little bit about how I became a physics teacher, and then some of the things that I've learned over the 42 years that I've been teaching. And I hope that some of it's useful or might be interesting. I was an undergraduate physics major, and I was in my last quarter at the University of Georgia, so this is 1975. And I knew my grades weren't going to be good enough to get into graduate school. And so I said, what am I going to do? And so I made an appointment at the job counseling center. And so I was down there with about 10 or 12 other people, and they gave us this little presentation. So here's how you write a resume. Here's how you sign up. At that time, you could sign up for job interviews. And towards the end of this little presentation, they said, well, and of course you're going to want a suit and a tie. And at that time, I didn't have a suit and a tie. I had the usual, long hair and cut-off jeans that college students in the 70s wore. And at the very end of that presentation, they looked straight at me and said, now, of course, you're going to want to have a nice, neat haircut. So I realized that I probably wasn't going to be cut out for the corporate world, and I walked out of the building, and I had all this material, and I saw a trash can, and I threw it away. And so I was struggling about what I was going to do, and fortunately, though, kind of on a whim, I sent in an application for the Peace Corps. Now, how many people here have been in the Peace Corps? Oh, no, I figured there would be a few. Okay, yeah. I sent this application in and not really thinking too much about it and almost forgot about it. And then right at the end of the quarter, I got this package that said, would you like to go to West Africa and teach high school physics? And I talked this over with my parents, and they said, this is a terrible idea. They really thought, surely you can find a job, a real job. But in any case, in August of 1975, I got on a plane with about 120 other North Americans, and we went to West Africa to teach. Most of us were going to be teachers. I have a few pictures from that time. That's a typical classroom. That's actually a middle school classroom, but that was the kind of classrooms that I was in. This was a really wonderful experience. I'd never been out of the southeast as an adult, southeast of the United States. And I had to learn to teach, for one thing, and I learned a lot about myself and about culture. This is the market where I did all of my shopping, grocery shopping, so it was really quite an experience. One of the things, of course, this is way before technology, you had to make an appointment to make a phone call back to the States. And so in the whole 2 years I was there, I called home 2 times. So 2 phone calls home. That was the only communication with home. Letters would take 2 weeks to get back. So it was pretty isolated. I got to travel a lot. I got to go to a lot of different places in West Africa and see a lot of different cultures. That was also very interesting. I did see elephants, and it was just really an interesting experience. I got to go as far north as the Sahara Desert into areas that are now restricted, that are controlled by Boko Haram, and you can't go there anymore. And I also got to see Timbuktu. This next slide is the landing at Timbuktu on the river. And then that's Timbuktu. One of the great things that happened to me is the training period. This was the family I lived with when I was during part of the training. So part of it was cultural. They taught us a little bit of the language. They taught us some of the cultural customs so that we would be able to function. And we also got some excellent teaching education. There were 2 guys, and I really am sorry that I don't remember their names, but they really changed my life, my teaching life. They were 2 Ghanaian teachers that were nationally known as being expert teachers. And they took the 6 of us, I think, that were going to be physics teachers. And for 2 weeks, they trained us. And one of the things they did was, after showing us the book and the syllabus and all of these things, they rounded up some students for us to practice in front of. And then they gave us feedback. And how many people here have had a peer review? Somebody comes to your class. It's really an excellent way to get some feedback. And these guys would sit us down and say, here's what you did wrong, and here's what you did right, and here's how you can improve. And one of the most important things, I think, that they taught me in that in that 2-week period was, they said, now look, Ghanaian students are going to be very polite and respectful. They're not likely to ask you questions. You're going to talk, and you're going to think they're understanding because they're shaking their heads, but they're not going to understand what you're saying. So you have to do something. And really, when you think about it, our students here don't like to ask questions, right? There's all kinds of good reasons for students not to ask questions. Sure, you might have a few students who are outgoing who like to ask a few questions, but for the most part, they don't like to speak up and show their ignorance. And so, these Ghanaian instructors said, here's what you need to do. You need to stop every 5 or 10 minutes and go around the room and ask the students some questions and find out what they're thinking. And so I entered my very first classroom with kind of an idea of active learning, of interacting with the students and finding out what they understood and not just what you're telling them. So, and like I said, this changed my whole life because I began to think about that from the very first time I was in a classroom. The very first thing I learned, even before I hit the classroom, was ask questions. I eventually did go to graduate school, and I ended up teaching at Indiana University Southeast in a tenure track position. And I was fortunate enough to encounter early in my career some other people who greatly influenced me. I think when you think about questions, what kinds of questions can you ask students to find out what they're doing? Well, early in my career, I ran across Paul Hewitt's book. Now, Paul was also a Millikan Award winner. These are great questions. I use them in all of my classes. I use them in the upper level, lower level, science majors, non-science majors. They're just really a wonderful set of questions. I also owe a debt to some of these people. Many of these people are also Millikan Award winners. They have lots of really good research that shows that their ideas work in the classroom. So if you don't know them, you should probably find them. These are just the ones that I encountered early in my career, and so they had a bigger impact on the way I taught. The idea is to interact with your classroom. Now, having said that, I think we have to recognize that there's too many ideas here. You can't do them all. And so we all have our own styles, right? We all have our own way of doing things, and our own way of speaking, our own way of dressing. We're all individuals. And so I think that's one of the things that we have to remember is, different techniques are going to work differently for different people. And finally, after a lot of experimentation, I had my own style. Okay, so after I'd been at IUS for a few years, the dean came to me and said, we have a degree program in chemistry and math and biology. We don't have a degree program in physics. In fact, I was the only physicist there. And so he said, would you write a proposal? So I did. I wrote a proposal for a physics degree. This was about 1988 or so. And it took about a year to get it through all the committees. So there's committees on our campus, on the main campus, the higher education committee at Indiana for the state of Indiana, the board of trustees, all of these people. And so I got it through all of the hoops, and it was ready to go. I came back to our administration, and I said, "Okay, we're ready to go. I'm ready to hire 2 new faculty," because that was what the proposal was. See, I already saw some people smile when talking about 2 new faculty. Yeah, you can imagine what the response was. So I couldn't start the program because I didn't have any faculty. So I thought about this for a while, and so one of the things that I realized is I could have stole students from the chemistry department or from math or something like that, but I decided, well, where most of the students are non-science students. So what I would do is I would try to get some non-science classes. And so this turned out to be something that occurred over a longer period of time, and I learned a lot. It was really worth doing. One of the first classes that I got involved with was the history and philosophy of science. This was with Bill Rumsey in the philosophy department. And one of the first things I learned in this class was there is not a scientific method. It doesn't exist, okay? If you look it up in Wikipedia, you can find something, but there really isn't a scientific method. How many people have heard of Karl Popper? So Karl Popper had the idea that, okay, at least science has to be falsifiable. You have to be able to prove whether it's right or wrong. But even this doesn't hold water, okay? Think about Newton's laws. We have actually proved that Newton's laws are wrong. If you go to high speeds or very small, it doesn't work. You've got to do something else. String theory, we cannot prove string theory at this point, but we don't want to throw it out and say it's not science, right? So there's a lot of problems with defining exactly what science is. Hypotheses, for example. So here's a testable hypothesis. My hypothesis is that if we go door to door around Washington and record how much money somebody makes and how many umbrellas they have, there will be a positive correlation between money and umbrellas. Perfectly testable hypothesis, right? But it's not science, okay? There's something wrong with that. So I think it turns out that these guys aren't just doing fluff. They actually have had some very careful thinking about trying to decide what it is that we're doing. The biggest thing that's missing, if you look up a definition of the scientific method in Wikipedia or a grade school textbook, the biggest thing that's missing is the creativity part. Karl Popper also said this, and I think I think that's what Einstein was getting at when he said, imagination is more important than knowledge. It's where the ideas come from, okay? And my 2 favorite examples are Barbara McClintock, who had an imaginative way of thinking about genes and thought that maybe they could move around. And she went to the laboratory and proved that that was actually correct. And of course, Frederick Kukulé dreamed. In a dream, he had a dream of a snake holding its tail and rolling down a hill. So then he went to the laboratory and figured out that the shape of the benzene molecule was circular. So it's the ideas. We have to start with lots of ideas, some of which are going to be crazy, but to do that, we need lots of different kinds of perspectives. And I think that's one of the things, and I see that at this meeting, is that we're working very hard. The number of women PhD physicists is only about 20%, and the number of minorities is only about 13%. We need to change this, okay? We need lots of ideas, lots of different ways of thinking about things. And that's one of the things I learned early on in teaching this history and philosophy of science class. So that was one class. I also started thinking about another class, and this was an environmental physics class, so energy and the environment. You should look around on your campus. Chances are there's some sort of program that's called sustainability or environmental studies. And if you look closely at that program, you'll find out that the actual courses that the students take often don't include very much science. There might be a couple biology courses, But you can have a degree in sustainability and not ever know about the first and second law of thermodynamics. So this is a window, this is an opening where you can say, well, I can add that class. I learned a whole bunch. In fact, I had so much information, I ended up writing 2 different books. And you can, if you look on Amazon, you can find both of them. I had to write a second book because environmental issues change really quickly. The laws of physics don't change that fast, but the environmental scene changes really, really fast. How do you get students interested in the second law of thermodynamics? Well, you tell them that for every $1 that they put in their gasoline tank, 70 cents turns into heat and is wasted, okay? How many people have a car that turns itself off at a stop sign so as to save gas, right? Yeah, great idea. So how much does that actually save you? Well, idling loss is only about 4 cents on the dollar. So that kind of gives you an idea of how difficult it is to get around the second law. If people are struggling with 4%, and you want 70% is being lost. Inevitably, in an environmental class, students will start asking, why don't we switch to renewable energy? Okay, and the answer is economics. Okay, it's pure money. That is it. If you look at windmills, for example, the cost of windmills have been relatively inexpensive. They've been cost competitive with fossil fuels for almost a dozen years. What's the biggest growing renewable energy? Wind energy, okay? Solar cells have just now reached parity with fossil fuels. Some of this is because there's very cheap solar cells coming from China, and I'm not sure with tariffs whether they're going to keep coming from China. But in any case, I would expect in the next 10 years we're going to see a lot more solar energy just because of the cost. The bad news is this is happening really slowly. In 2005, 88% of the US energy was fossil fuels. We use approximately 100 exajoules, and we have used about that much for the last 10 years. So 88% was fossil fuels of our primary energy. In 2015, so that's 10 years later, 86%. Okay, so we've only been able to reduce our fossil fuel dependency by 2% in 10 years. Okay, so this is a very slow process. It's not going to happen next year or then the year after. I couldn't resist putting a few resources in case you're interested in environmental stuff. These are all free. Gapminder is a neat little interactive. How many people have seen Gapminder? Yeah, it's kind of a neat little thing where you can get at some of the social issues, so you can compare, say, GDP versus per capita versus energy use per capita in different parts of the world. And because it's a graph that changes over time, you can see the evolution over time. These kinds of issues are really important for environmental questions. When I was born in the early 50s, there were less than 3 billion people in the world. We're now at more than 7.5 billion people. So in less than 50 years, the population has doubled. This didn't used to happen. If you go back 200 years, that didn't happen. Okay, but we're in a special period here where all of a sudden there's twice as many people, twice as many mouths to feed, twice as many resources being used. So it's a special time. Another project that you can have your students do is the Argonne well-to-wheels spreadsheet. This allows you to compare total energy, so energy for the fuel, energy for the car, and pollution for different kinds of transportation. And you can compare transportations that don't exist. So for example, a hybrid diesel doesn't exist yet. How does that compare with a fuel cell that's running hydrogen that's generated by renewable energy? So you can actually get the total energy for those two transportation modes and the total pollution. So it's kind of a neat student project. And then if you want to do some of your own climate modeling, the last one there is also a free downloadable climate model. It's a real model that's just a little older, so it's not as elaborate, so it'll run on your desktop. And so you can change the parameters and do experiments. Okay, and so there was one more class that I ended up teaching.
Frequency shifts are summarized by the following table.
So that was an instrument with sulfur hexafluoride in it. Sulfur hexafluoride is the sound travels slower. It's a greenhouse gas, so I wanted to get that on YouTube so I didn't have to do it over and over again. And so that was what we did, was put it on YouTube. This was a really great class. The first couple of times I taught it, I didn't have enough material. I was scrambling to learn more and more stuff. The students were great. They would come in with their instruments and show me stuff and ask questions, and that was really a fun class. Okay, so what happened? Okay, so 88 was the first proposal, and we eventually did get a physics degree. It took a while. So academia moves slowly, but you can eventually you can change academia. Okay, you can get things to change. Okay, how many people are a one-person department? So you're the only physics person there. Yeah. So it's kind of lonely, right? And so who do you talk to? You got to talk to the people around you, right? And they're not physicists, okay? I was at Indiana University Southeast for about a dozen years as the only full-time person. And next door in the office to me was Ray Wisman, who was in computer science. And Ray was a great guy, but he came into my office one day and he said, I've got this software and I can get it to work on my Unix box, but I can't get it to work on my PC. This is in the early 90s. And he said, could you try on your Mac? Can you try to get this to work? And I really didn't want to, it's like, that's computer science. I don't want to do this. But I realized I wasn't going to have anybody to talk to if I didn't humor him. And so I put and the software worked, okay? And what it was web serving software. So I ended up with the second website on the IUS campus. Now the main campus had a website, but our campus didn't. And so my desktop computer was the second website. And we ended up having a lot of fun with this. We did a lot of projects. One of the projects was at this particular time, we ran workshops for faculty and staff who had never seen the internet. So there was a lot of people who didn't know what it was and didn't know how to surf the internet. So we ran these classes. We'd have 20 or 30 faculty and staff. I remember one, we were about 30 minutes in, and there was a lot of giggling going on in the back. And I think you probably can figure out what they've encountered, but it was the Chippendales. So and nobody knew that was out there, and so somebody found it. So one of the things that I learned from this is listen to your colleagues. Okay, they have lots of good ideas, and you might learn something. You might have some things that are useful. After we kind of got started and started putting our syllabuses and stuff on a website, we went to the IT department and said, gee, this is really great stuff. The campus ought to have a website. Yeah. It was really hard to talk them into. They said, "Oh no, this is just a gimmick. It's not something that'll ever amount to anything." But we eventually did get them to have a website for the campus. Another time, Ray came into my office, and this is probably the early 2000s, and he came into my office and he had an old Nokia cell phone. And he said, "Do you know you can program these things?" And no, I didn't know that. And he showed me a program that he had written to do a Fourier analysis of the sound coming in the microphone. And I thought, that's pretty cool. I think I should buy a cell phone. And this is a pressure gauge, so it's under some water there. You put it in a plastic bag, and it'll measure pressure. And of course, we now know that cell phones have all of these sensors on them. So instead of sending students home just to do homework, we can send them home to do laboratory work. Okay, I haven't seen very much of that. I haven't seen people doing this, but you can send students home and say, hang your cell phone from a pendulum and measure the acceleration. And you can have a few extra cell phones or tablets or something on hand to loan people who don't have the right sensors. So that's one thing I think that I haven't seen very much of, but I think that's something that's very useful. Also, if you go to developing countries, you find out that a lot of times science equipment is lacking. But a lot of people have cell phones, and some of them are smartphones. So I would like to encourage the AAPT to kind of support some of this, to develop some laboratories, because the data is good on these things. They're accurate. So that we would have lots of laboratory exercises that aren't just limited to the 2 hours at the school. I have a couple other ideas that I'm going to throw out in case there's somebody who's really interested, and that is crowdsourced data collection. The 3 projects that I've heard of that I happen to know about, and I'm sure there's others. In the upper left is a project that was in the Netherlands, and they had a lot of people download an app, look up at the sky to get the opacity of the sky, so you get a measure of pollution. And you can do that across the whole country. The CRAFIS, that was cosmic rays. Your camera on your cell phone is sensitive to cosmic rays. So they had thousands of people download an app and globally measure cosmic rays. Magnetic field can work the same way. I think the magnetic field is still a project that's ongoing. You can download the app and measure the local magnetic field, and so you can get a global measurement. So just ideas in case somebody's looking for something to do. You could put a whole class on a Ferris wheel and have them measure the acceleration at the same time at different places on the Ferris wheel, or a roller coaster or something like that. Okay, after you've been teaching for 10 or 12 years, 15 years, you think, oh gosh, I've got this. I know how to do this, right? I'm an expert now, okay? I'm an expert not only in teaching physics, but everything else. And you start looking at your students and you think, students today, they're just not as good as they used to be, okay? They're not as smart as they used to be, and they're just not as good. Well, this is an idea that's been around for a while. And I think what it really is that we just get better at figuring out what students don't know. So how do you get past this? How do you remember what it's like to be a student and kind of regenerate yourself? And one way to do it, and this was mentioned, I think, in yesterday's plenary speaker, become a student again, okay? And the way this happened to me was in 2005, I was looking for a sabbatical. And I was in a committee meeting, and for some reason, the committee ended early. Faculty committee meetings don't usually do that. And so we were so stunned, we just sat around and talked. So I was saying, what am I going to do for my sabbatical? And one of the Spanish teachers, Amy Zink, she said, well, why don't you come to my Spanish class? Maybe you would be able to go, to, have enough Spanish to go to South America or Central America and on your sabbatical. And, it was kind of a glib sort of, half-hearted suggestion, and I sort of equally glibly said, sure, I'll do that. And so I did. So here I was, 53 years old, and there were about 24 students in the class, and they were all 20 and under. And I don't know how to tell you this, but 20-year-olds have good memories. When you're 50, you don't have a good memory anymore. And I thought I was going to be good. I thought, hey, I'm a professional student. I've been doing this all my life. I even had a semester of Spanish a million years ago. And this is going to be easy. Well, these students ran circles around me. I mean, students are just as sharp as they always have been if you get on a level playing field. And what's more, this class was a very interactive class. In fact, Amy's class is the most interactive class I've ever seen. She had us standing up in front of the class, singing little dumb songs about the irregular verb tenses. She had us playing charades. She had competition for vocabulary words among people. And so here I am with all these 20-year-olds trying to remember vocabulary words. And it was humiliating. I mean, I made probably the equivalent of a B+, but it was really a stressful situation. One of the things, so there's 3 things that you can get from this. One of the things is you're going to, if it's a good teacher, you're going to learn something about interactive teaching from them. And I did learn some things to take away to my class. The other thing is you're going to remember what it's like to be a student. And that's what happened to me. It's like, oh yeah, being a student's hard. It's hard to learn new stuff if you're not familiar with it at all. And then the other thing is that I actually did eventually, took much longer than 1 semester. I did eventually learn enough Spanish that I was able to go to South America on a sabbatical. And while I was in Argentina, I made contact with Zulma Gangosa at the University of Cordoba, and she and I worked together for me to get a Fulbright. So I was able to go back for 3 more months as a Fulbright. So it paid off. The embarrassment actually did eventually pay off. Ray Wisman and I then went back and did a workshop on cell phones. And so here's some teachers who are about to drop a tablet that's going to measure the acceleration of gravity. So it was worth doing. In this last little bit, I'm going to talk about books. And now when you think about books, I mean, they're still a central part for most of our courses, right? We still use textbooks. And so I began to think about what is a textbook. And if we were to resurrect Gutenberg and show him how on a tablet how to turn the pages, he would recognize that as a book, right? He would say, oh yeah, this is a book, okay? In other words, not much has changed with books for almost 600 years, okay? And so maybe we should think about how we do books. One thing you can think about is maybe we don't need books. Right, we've got the internet, okay? We got Wikipedia. Maybe we just don't need books at all. But we all know what this is like, okay? You know, trying to use the internet, it's it's too much, okay? It's too much. So I think so. What is it that a book does? Well, one of the things it does is it narrows down the scope, and it ends up telling a story. So books tell stories. And I think that's really important. I couldn't resist. 2 of my grandkids are in the picture there. So, if you've ever sat down with little kids and read them a story, you know that it hooks them. There's something that really gets them. And there's a good reason for this. There's now research that actually shows that your brain reacts differently to stories than it does to facts. So if you take two groups of people and you give one a bullet list, and then you give another group a story with that same information, the group that heard the story remembers it longer, it has better integrated the information, and holds on to it longer. So I think that's one thing that we should think about when we think about textbooks. I know how many, if you're like me, your student evaluations, what's the lowest scoring thing on your student evaluation? The book. Okay, that's usually for me. That's what I get. So I got to thinking about how to make a book tell a story, how to get the students involved in the story of the book. A million years ago, I did some research with nonlinear waves, and I was trying to figure out how to put that on a website. So I wanted waves on a website. Unfortunately, I ran into Wolfgang Christian, and we were able to do that. So we were able to put together a set of simulations on the internet. And we eventually turned that into an ebook, so it's on iTunes. For the duration of the conference, you can download it for free, okay? And also the other book that I'm going to talk about is freely downloadable. It was really expensive. At first, it was $3.99, but in any case, and we also have it on the Compadre website. So if you're an AAPT member, you can get to everything on Compadre for free. And I'm going to show you a Compadre version of the other book. So this was very took us a lot of work, but we made an iTunes EPUB. I'm going to demo it a little bit here. So that's what it looks like. There are 32 chapters or so, and each chapter has a little explanation and a simulation and some questions. And so this is interference. The questions require you to use the simulation. So you can't get to the answers of the questions without actually doing the simulation. So this requires that you're involved in the story of the book. You're actually got some hands-on things where you're actually, having to do something. This is the Doppler shift. You can actually click in it and get distances, and then once you get the distances, you can actually show it verifies the correct equations. And once again, questions that require you to do something to the simulation in order to get to the answer. This is electromagnetic waves. So that was to demonstrate electromagnetic waves. And once again, questions to get the students to actually do something with the text. Now, these simulations look like they're really hard to do. And, well, yeah, they are actually. But they're not as hard as they look, okay? And the reason they're not as hard as they look is we're using a package of tools that was generated by Francisco Esquembre, Paco Esquembre, and he's here at 1:30, session EB. So session EB at 1:30, he's going to show you how this stuff works, okay? And it's not that hard. You don't have to be a programmer to actually make these simulations. That's a little pitch there. The other book, I taught this physics of sound course, and I ended up with enough material to put that into a book. So this is the Compadre version, and the Compadre versions of both of these are free if you're AAPT, you get into it. And I forgot to mention the Wave book is in Spanish as well. There's a Spanish version. The sound book has 33 chapters, I think. And so this first one is the waveforms and what they sound like. In this book, I have many more links to YouTubes and things, other resources. So that's one thing about an electronic book is you can have links to other resources. Okay, so, and once again, the students have to read the questions and then play with the simulation. The next one here is the Fourier series. So you can see that there's links to other things, YouTube's Wikipedia definitions and some text, and then the simulation with the questions. And then the last one is beats, and I'm sure many of you have done beats with 2 tuning forks, but what if you can change the frequency between the two? And you end up getting a different phenomenon. So there's beats. So that other sound is something called dissonance. And musical instruments, it's impossible to find a tuning system for musical instruments that gets rid of all dissonance. But you want to minimize that because it doesn't sound very good. So if you're teaching students about why is there dissonance, this is one way to start. Okay, so I think what I was trying to do, and I'm not sure if this is really the best way to do it, but one way I was trying to get students to think about the text as something that they interact with, almost like a story, and have to participate in. All right, so I don't think that we're in the business of entertaining students, but we want to kind of engage them, okay? And the textbook is one place where we haven't been able to do that really. We haven't done it as well as we could, I think. Okay, so as a summary of what I've learned in my 42 years of teaching, get your students involved, get them, ask them some questions, find out what they're thinking. Teach non-science majors. I think one of the things about, if you have a bunch of science majors, they sit down in the classroom and they're ready to go. They're like, okay, is that a plus sign? Okay, and they're focused on it. They have an idea of what the limits of science are. Non-science students are much more interesting. Okay, they ask questions that you just have never thought of before. So you'll talk about resonance, and they'll say, okay, my instrument has resonance frequencies, my vocal cords and mouth have resonance frequencies. Do my bones have resonance frequencies? Do trees have resonance frequencies? I mean, they start asking questions and you think, okay, I have to think about that. Do they? Or I'm not sure. What circumstances? So you get a broader spectrum of questions. Your colleagues have great ideas, even if they're not in physics, and you can steal them. Okay, so you can get a lot of new ideas. If you do become a student again, and it doesn't have to be a language class. I know yesterday the presenter talked about ballroom dancing, so that's also somewhere you can embarrass yourself. Guitar playing. Okay, so there's lots of ways to become a student again and remember what that's like. You'll get 3 things out of it. You'll learn a new talent. You'll learn something new. If it's a really good teacher, you'll learn something about how some new interactive teaching methods. And then you also will remember what it's like to start over from scratch as a student. And then the last thing is to tell a story. So try to get, once again, I'm not saying we have to entertain people, but let's try to get them more involved. All right, so I hope that some of this has been useful, and if not useful, at least entertaining, and I'm going to stop there. So.
We do have time for some questions, so if anyone has a question for Dr. Forinash, would you please Then, I don't know if we have a microphone out there available or not, but anyone have a question?
George, can I ask?
Yeah, certainly. Whoever yelled. So I don't see anyone. I have a question here. I'm just curious about, when you were in the Peace Corps in Ghana, you said they would not ask questions. Did you ever get over that barrier where the students were comfortable enough that they would sit there and ask questions? And
Not really, yeah.
no.
Yeah, they were extremely polite. It was, and any teacher at that time, any teacher that was in that system in Ghana was referred to as master. So you would, students, if they had to address you, they would say, "Master," which is totally freaky. I mean, but you couldn't convince them to do otherwise.
Yeah.
So
it was the barriers were just too high, and
there was a great respect for education and teaching because it was clear that education was a way out of poverty. So.
I like asking questions, so I'm glad to have the opportunity to ask you a question. I wonder, regarding environmental physics, I wonder if you've read the book A Planet Remade by Oliver Morton, and if you had, would you comment?
I have not read that.
Please read it. It's an excellent book on what's going on in the climate.
Other questions out there? Anyone? Okay, well, please. Oh, yes, we have one more. Great.
Look like no questions.
Right. Well, if there are no further questions, please thank our speaker again. Okay, that I declare this session closed. Thank you.